our theme for the day. Our theme for the day is going to be scale drawings. So let's get in the mindset of doing some scale drawings. This is one of my favorite things to do. I'm really happy we're going to get to do it today. Alrighty. Awesome, awesome, awesome. Welcome, everybody. So let's get this show on the road. Our first question says, determine if the two figures could be scale drawings, and you're asked to explain. So before we begin, what is a scale drawing? What is a scaled drawing? What's a scale drawing? What is a scale drawing? What do we think? What is a scale drawing? And ask one more time, what is a scale drawing? I want to hear some more participation here, folks. Waiting on one. What's a scale drawing, everybody? Right, exactly. It's going to be, we're looking at different size figures that are going to be similar, and then we're going to see corresponding sides. There's going to be a relationship between the corresponding sides. Excellent. Two figures where there is a relationship between the corresponding sides. Two figures, there's a relationship between each of the corresponding sides. So, in order for this to be a scale drawing, the scale factors, I'm double typing here, all have to be the same. In order for this to be a scale drawing, all of our scale factors need to be the same. What is a scale factor? What is a scale factor? We've done this since before break. What is our scale? What is a scale factor in general? What is a scale factor? Needs more participation here, folks. We got a lot of great scholars in this group. Let's make sure we are participating. What is a scale factor? What do we think? Let's send some individual message to people. What is a scale factor going to be? Looking for some answers from some people. I want you guys to do the lifting here. That's all right if we're not totally sure what it is. I see some people saying they're not totally sure. So a scale factor is going to be the number that we multiply one side by to get the length of the other side. So the scale factor captures the relationship between two figures. And it's going to be represented. We represent it as a number. All right, awesome. Got some good guesses there as well. So our formula to find the scale factor is going to be scaled side equals the scale factor times the original. Does this look familiar? Does this formula look familiar to folks? Times the original. Does this formula look familiar to us? Is this formula familiar? Some more participation here. Is this formula familiar? Scaled equals scale factor times original. Yes, awesome. See some yeses rolled in. Roll in. Excellent. So if we're going from A to B, that means that A is going to be our original, and figure B is going to be our scaled side. Figure B is going to be our scaled side. So if we're taking this side first, we're going to be looking for our scaled side is going to be 24. Yes, please write all of this down on a piece of paper. Equals our scale factor, which we're trying to find, times the original length, which is going to be 8. Then to solve for our scale factor, we divide both sides by 8, divide by our coefficient. Divide both sides by 8. And 3 is going to be our scale factor. Awesome. So that's how we find our scale factor. This is how we find our scale factor. We plug in values for the scaled and original sides and solve for SF. Alrighty, any questions about that? Any questions? I know it's been a while since we did that. Any questions about that? know it's been a while since we last did it. Awesome, not seeing any questions here, and so I'm feeling good to move on to the next side. So we're now going to test if all the sides have the same scale factor, see if these are scaled figures or not. So let's take a look at this side, 11 meters, and we're going to scale that to be 33 meters. So we're going to have scaled equals the scale factor times our original. Awesome. So which side is our original? 11 or 33? Which one's going to be original, 11 or 33? What do we think, folks? What do we think? 11 or 33? Awesome, right, we got a bunch of people saying the correct answer here. Our correct answer here is going to be 11. Our original side length is going to be 11. We're looking for what the scale factor is going to be. Then our scaled side is then going to be 33. And we solve for the scale factor. We're going to solve for our scaled factor. How do we solve for the scale factor? Excellent job. Message. Awesome job. We're going to divide both sides by 11. Excellent. Divide both sides by 11. And we're going to get 3 is our scale factor. 3 is going to be our scale factor. Awesome. So it looks like we're going to have the same scale factor for all of them. And let's make sure that we are participating here. I'm seeing not everybody participate. So let's make sure that we are doing that. Alrighty, let's take a look at our last side. Let's take a look at our last side. Let's go to black. We're going from 14 meters here over to 42 meters here. So once again, we have our same formula. Scaled equals the scale factor times our original. Original here is going to be 14. You do the scale factor times that. That's going to be our scaled side, which is going to be 42. Sorry, scale factor. So what is our scale factor going to be? What's our scale factor going to be? Everyone take a second to figure that out. So scale factor going to be, what do we think? So you got one person getting it. Great. So exactly, we're going to divide both sides by 14. And we're going to get 3 is our scale factor. Awesome. So if all of our scale factors are the same, are these two figures scaled figures? Are they scales of one another? If all 3 of our scale factors are the same, are these 2 figures going to be scaled figures? Seeing people say different answers. Awesome, right. Since all 3 sides have the same scale factor, then these will be scaled figures. Excellent job, everybody, on this first question. Awesome. Any question about this first one? It's going to set up us really well. Those that have been participating are going to really be able to knock the rest of us out of the park here. So let's make sure we keep our participation up. Make sure you guys are doing the lifting, and let's keep moving and grooving unless there's any questions. Any questions? I'm seeing a bunch of no's. That means that we're feeling good about this. And let's move on to our next question. All righty. What is the scale factor to go from, let me get my pen out, from figure A to figure B? So if we're going from figure A to figure B, which one's our original? Which is our original? A or B? If we're going from A to B, which one's going to be our original, A or B? Right, A is going to be our original because we're starting at A and then we're moving to B. We're starting at A and then we're moving to B. So our original and B is going to be our scaled side there. Alrighty, so are we using the same formula as last time? Same formula as last time, or a different formula? Very different formula. Awesome, seeing a bunch of people saying the same. Excellent, excellent. Right, we're gonna use the same formula as last time, which is going to be scaled equals our scale factor times the original. And our scaled side, let's do 4 and 6. Which one's gonna be our scaled side, 4 or 6? Actually, let's do, sorry, I'm gonna change that. Which is our original side, 4 or 6? So original side, 4 or 6? I'm seeing different answers. If we're starting at figure A, if figure A is our original, that means that 6 is going to be our original side length. We have our scale factor here, and that means that our scaled side is going to be 4. So we're actually shrinking it here. We're going from a larger one to a smaller one. So in this problem, we're going to be, sorry, let me type this out. We are actually scaling down. We're actually going to be scaling down from larger to smaller. So we divide, oh, did I lose someone? Looks like I did. Divide both sides by 6, and we get 4 over 6 is our scale factor, which can be simplified, scale factor, which can be simplified to 2/3. So what is our answer? A, B, C, or D? A, B, C, or, sorry, A, B, C, D, or E? What is our answer going to be here? A, B, C, D, or E? What do we think? A, B, C, D, or E? Excellent. It's going to be E, 2/3. Awesome job. Our answer is going to be E. Do we have any questions here? Any questions here? Any questions here? Any questions here? I'm not seeing any questions. Alrighty, let's take a look at our third question. Let's take a look at our third question. I see people hopping back in. That's excellent. Make sure we're participating to get full credit for this today. It is not just enough to sit here. You have to be participating in the lesson as well, because I need to see that you are learning and getting the most out of our time together. Alrighty, let's take a look at this. Rectangle ABCD is similar to rectangle EFGH. What does it mean for shapes? Let's say rectangles. Rectangles to be similar. What does it mean for rectangles to be similar? What does that mean? What does it mean for rectangles to be similar? What do you mean? Let's take some guesses. Let's take some guesses. It is 100% fine if you are not correct. Right, so they are going to be quadrilaterals. Let's focus on the word similar. I'm going to actually highlight that in a different color. Let's focus on our word similar right here. What do we think the word similar means? What does similar mean? What does similar mean? What do we think similar means? Similar means, excuse me. Right, exactly. It's going to mean alike, or they are going to be scale drawings. In this one, not the same. They're going to be scale drawings, which means that all of our scale factors are going to be the same. Alrighty, so what is the scale factor from rectangle ABCD to rectangle EFGH? Since this is a rectangle, we know that we have two sets of equal sides. So that's going to be 15 and 25. Oh, and if we're going from ABCD to EFGH, which is the original? ABCD or EFGH? Which is going to be the original if we're going from ABCD to rectangle EFGH? What's the original going to be? What do we think? What do we think? What do we think? Right, awesome. ABCD is going to be our original. Excellent, that's going to be our original. And this one right here is going to be our scaled one. We're scaling up this time. We are scaling up this time. Alrighty, so we have scaled equals our scale factor times the original. Scaled is going to be our scale factor times the original, so let's do 6 and 15. I want everyone to write out the equation for me. Write out the equation for me. Plug in the values for scaled and original. So I want you to write out the equation for me, scaled and originally. I'm going to be writing out our equation. What do we think? What do you think we're going to plug in for scaled? We're going to plug in for the original. What will we substitute for scaled? What will we substitute for original? What do we think? So our original is going to be ABCD, so that's going to be 6 inches right here. And multiply our scale factor by that. That's going to be equal to our scaled side. Oops, that should be an equal sign. Our scaled side, which is going to be 15. Now, how do I solve for the scaled? How do I solve for my scale factor? How am I going to do that? How am I going to solve for my scale factor? Need some more participation, folks. I need more participation. We should all be answering each of the questions. I need us to be participating here, everybody. Excellent, there we go. We're going to divide both sides by 6. Divide both sides by 6, 15 over 6. Excellent job. Is going to give us 2.5 is going to be our scale factor. So our answer here is going to be B, 2.5. Our answer there is going to be B. Any questions here? Any questions about this one? Any questions here? Haven't answered any questions at this time. If there's no questions, let's take a look at question number 4. Question number 4, I really like this question. It's probably my favorite one. Question number 4. Alrighty, on a map of the Northeast United States, the map scale says that 1 centimeter equals 5 miles. The distance shown on the map between New York City and Rochester is 5 centimeters. What is the actual distance? So in this problem, we are still going to use our scale factor formula. And what is the scale factor? It's given to us in the problem. It is given to us in the problem. What is our scale factor going to be? We have scale factor times original. Right, I'm seeing 5. It is going to be 5. Why is it 5? Why is it 5? Why is it 5? Why do you think it's 5? Let's go back to the text of the problem. Why is it 5? It's not the distance they have between each other. It's going to be right here. This tells us our scale factor. Remember, the scale factor is the relationship between an original and another shape. So here we have 1 centimeter equals 5 miles. So this here is going to represent our relationship. So we're looking for the actual distance shown. That's going to be a scaled distance. And our original is 5 centimeters. So our scaled is going to equal our scale factor, which is 5, multiplied by our distance, which is going to be 5 as well. So what is our scaled distance going to be? What is our scaled distance going to be? What will our scaled distance be? What is our scaled distance? What is our scale distance? Not 250, it's just going to be 5 times 5, which is just going to give us 25. Awesome. Yep, exactly. It's going to be 25. Oh, welcome. We have a new friend joining us. Awesome. Going to be 25. Let's try to be. So what's our answer going to be? A, B, C, D, E, or F? A, B, C, D, E, or F? Right, we're going to have F. It's going to be 25 miles. Is going to be our answer. So the actual distance is 25 miles. The actual distance is 25 miles. All righty, awesome. Any questions here? Any questions here? We have one more question to go. One more question to go. Any questions before we go to last question? All righty. Let's hop to our final question. This is going to be question number 5. Question number 5. It's going to be very similar to the last one. The scale used to make a scale model of a car for a giant display is 1 inch equals 4 feet. The length of the scale model is shown in the drawing below. How many feet long is the actual car? So what is our scale factor going to be? What's our scale factor going to be in this one? What do we think? Right, I see 4. Why is it 4? Why is our scale factor going to be 4? Why is our scale factor equal to 4 in this problem? Not feet long. Think about what this. Think about what 4 feet represents. Think about what the 4 feet represents. Right, exactly. It's going to be the relationship between the model and the actual car. It's going to represent the relationship between the model and the actual car. So we've our scaled is going to be our scale factor is 4. Our original length is going to be 9.5 times 9.5. So what is our scaled length going to be? What is our scaled length? Oops. What is our scaled length going to be? What is our scaled length of the actual car? What's our scaled length of the actual car? What do we think? Excellent. It's going to be 38. And our car is definitely going to be in feet. How many feet long? So our answer is going to be D, 38 feet. All right. Any questions here? This is our last question. Any questions here about content? All righty. That's going to be it for today.